Okay, so you can see it here. हे जे आपण कपलिंग कॅपॅसिटर जे जोडलेले आहेत त्यांचं कामच आहे की त्यांनी फक्त AC सिग्नल पास करायचा, DCला जाऊ द्यायचं नाही. We know the property of the capacitor. Capacitor blocks the DC and passes only AC signal or varying signal. The signal which is changing with respect to time. Either it may be current or voltage. But it should change with respect to time. If it is not changing with respect to time, then that signal will be blocked by the capacitor. Okay, for example, DC current. DC means direct current. Here the current is not going to change with respect to time. It is constant. So it will capacitor will not allow that current to pass through it. Correct. So whenever there is a signal, capacitor will pass the signal. Whenever there is constant voltage or constant current, capacitor will block that voltage or that current. It will not allow to pass through it. This is the property of the capacitor, because Xc, that is capacitor reactance, is 1 upon 2 pi Fc. 2 pi Fc. So if F is 0, DC means frequency is 0. Xc will tend towards infinity. Xc will tend towards infinity. कॅपॅसिटिव्ह रिॲक्टन्स म्हणजे रेझिस्टन्स, कॅपॅसिटन्सनी पझस केलेला रेझिस्टन्स हा इन्फिनिटीकडे जातो DC साठी. त्याच्यामुळं इन्फिनिटी जर रेझिस्टन्स झाला कॅपॅसिटरचा तर सिग्नल डावीकडनं उजवीकडे जायचा प्रश्नच राहत नाही. करेक्ट. सो सिग्नल विल नॉट पास थ्रू द कॅपॅसिटर. सो DC signals never pass. Only AC signals will pass through the capacitor. Even slowly varying signals will also be blocked by the capacitor. Fast varying signals will be allowed by the capacitor. So lower frequency signals are blocked by the capacitor. Higher frequency signals are passed by the capacitor. This is the property of the capacitor. Correct? So this is the picture. This is the circuit diagram that we have drawn for common emitter amplifier. Okay. Now we want to analyze this particular circuit. You may modify this circuit, because as we know, we connect one more resistance in the emitter side. We can also connect a resistance in the emitter side. Here. This is Re. In voltage divider bias, we have connected one resistance in the emitter side, one resistance in the collector side, and two resistances on the base side. They are called as voltage divider arrangement. RB1 and RB2. That forms the voltage divider arrangement. Correct? So if you are connecting Re here in the emitter side, then you will also have to connect capacitor, bypass capacitor across Re or in parallel with Re. When you connect a capacitor in parallel with Re, what this capacitor will do? It will not trouble you for DC biasing, because Re we are connecting for DC biasing or stabilization, for stabilization purpose. Correct? So capacitor doesn't allow DC current, so all the DC current will pass through Re. Correct? So capacitor will not disturb your stabilization part. But when you connect a capacitor across Re, AC signal, whatever AC signal is there in the emitter side, that will be passed through the capacitor to the ground. That is called as the bypassing of the signal. Signal is bypassed by the capacitor. Okay? Signal is bypassed by the capacitor. So you can use one more capacitor here across the emitter. I will redraw the circuit again. परत आपण काढू. दिस इज युअर ट्रान्झिस्टर. Here is the emitter resistance RE. This is your RE. So what I will do, I will connect one more capacitor across RE. This is called as C, emitter bypass capacitor. I will connect one resistance on the collector side. This is RC. This is plus VCC. Correct? So I will connect voltage divider bias network here. This is RB1 and this is RB2. This is RB2. Now first thing what you have to do is you have to adjust the operating point. Correct? Before you use it as an amplifier, first thing what you have to do is this collector voltage, this voltage VC, okay, or VC I will call it as, should be halfway. It should be one half the VCC. It should be one half VCC. Correct? So VC should be one half VCC, because one half VCC means operating point is at the center of the load line. Correct? So you have to adjust this. How to adjust? You may keep this resistance as variable, slightly variable. You may vary that resistance so that IB will vary. IB will change. When IB changes, IC will change. IC will change. And when IC changes, VC will change. Or collector voltage will change. So in this way you can adjust your VC voltage to one half VCC before applying the signal. Still I have not applied any signal to this circuit. Now I want to apply the signal to the circuit because I want to use this circuit as an amplifier. I want to use it as an amplifier. So before using it as an amplifier, I should make these arrangements. You have to keep the operating point at the center of the load line. How to keep it at the center of the load line? Make VC equal to one half VCC. If VCC is 10 volt, make VC is equal to 5 volt. So automatically your operating point comes at the center of the load line. Very easy to understand. Correct? Now I want to use it as an amplifier now. So what I will do? I will use a capacitor here. This is called as the coupling capacitor. One more capacitor I will use at the input side. This is also the coupling capacitor. And here I will apply the signal. Whatever input signal I want to apply, I will apply that signal on this side. This is V in. Correct. And here I get V out. V out. Here I get V. Okay. So this type of arrangement we call it as the amplifier. This is common emitter because emitter is common. How the emitter is common? Because you may say you have connected a resistance on the emitter side. Now how emitter can be common? Yes, for DC signal it is not common because emitter is raised at higher potential than the ground potential, because we have connected a resistance RE in between the ground and the emitter. But for AC signals, as we know, capacitor will bypass that signal. It will provide a short circuit for the signal. So naturally, when capacitor C, emitter bypass capacitor C is providing the is bypassing the signal, AC signal. आपल्याला माहिती की कॅपॅसिटर काय करतो, AC सिग्नलला पास करतो. ज्यावेळेस आपण सिग्नल अप्लाय करू इनपुटला, त्यावेळेस एमिटरच्या अक्रॉस जेवढा सिग्नल तयार होणार आहे तो सगळा सिग्नल बायपास होईल कॅपॅसिटरमधनं. आणि तो ग्राउंडला जाईल. बिकॉज कॅपॅसिटर सी प्रोव्हाइड्स द शॉर्ट सर्किट फॉर द AC signal. It provides the short circuit for the AC signal. So you can say that now your emitter is at a potential equal to ground. C is providing the short circuit path to the ground. So your emitter is not at the zero potential or ground potential for AC signals. For DC signals, it is not at ground potential. It is above the ground. But for AC signals, since the capacitor C is providing a short circuit, it is at the ground potential for AC signals. So in this way I can say that this is common emitter amplifier. Emitter is common. It is at the ground potential for AC signals. Correct. So this way you can conclude. In the analysis part, when I say I want to analyze this circuit, in the analysis part, I have two types of analysis. One is DC analysis and second one is AC analysis. DC analysis we have already done, that is stabilization circuit. AC analysis we will have to do. Correct. Of course, for common base amplifier, I will do both DC analysis as well as AC analysis. But for common emitter amplifier, in the second chapter we have used all the circuits of common emitter amplifier. That's why I will not repeat the same part. So DC analysis is same that we have studied in the second chapter. Only AC analysis we will study in this chapter. Okay, so that completes the starting phase of the transistor amplifier. Tomorrow I will continue with the same lecture. I will go for analysis, DC and AC analysis. Correct? So I will stop here. I will stop here. Tomorrow at 2 o'clock again we will meet. Okay?